Hi Rocketeers, I'm Charlie Garcia, and today we're going to make some DIY carbon fiber tubes. Making your own carbon fiber tubes can be useful for all kinds of projects, from doing your own bike, making your own drone, or redoing the exhaust system on your car, but I care about carbon fiber tubes to make my own rockets. I have a big launch coming up here in a few weeks, and I've chosen to make everything on this rocket from scratch, including the airframe. Now, if somehow you're one of the people that hasn't heard about carbon fiber yet, carbon fiber is an incredibly lightweight and strong material, and it's a composite material made from two materials joined together to get the best properties out of each of them. In carbon fiber's case, that's an epoxy resin and the carbon fibers themselves. The carbon fibers provide the tensile strength and stiffness of the material, while the epoxy provides compressive strength and helps it hold its shape. There are a couple of different ways to make tubes out of carbon fiber, but these tubes are going to be wrapped from whole carbon fiber cloth. This project starts with an aluminum mandrel. I use an aluminum tube, which is sanded to 800 grit and then polished. I wrap this mandrel tight with a layer of mylar film. This is taped onto the mandrel so I can get a tight wrap, but just at the edges so I can remove it later. This type of tape is called Teflese, and it's coated in PTFE, so the epoxy doesn't stick to it. Once the mylar was wrapped, I closed the seam with a layer of flash tape to prevent any epoxy from leaking under the joint and sticking to the tube. I'm not going to bond anything inside of this tube with adhesives, so I'm using Stoner E236 mold release to help release the mylar film from the inside of the tube. If I did need to bond an additional structure, I'd use E497 instead, which cleans off much nicer and allows to get a good bond surface. The next step is to trim the fabric to shape. Carbon fiber cloth comes in a variety of weaves and weights. For this layup, I used 8-ounce carbon fiber in a standard weave. I wanted my tube to have roughly 50 thousandths of an inch thick walls, so I needed 6 wraps of carbon fiber. To get 6 wraps of carbon fiber, I simply calculated the circumference of the tube, multiplied that by 6, and used that as the length for the section of cloth that I cut out. I also elected to put a layer of 2-ounce fiberglass on top of the carbon fiber so that when I sanded the tube, I would be sanding through the fiberglass, which is not structural, instead of the carbon fiber. The 2-ounce fiberglass also has much tinier fibers that are much closer together, so it leaves a smoother surface finish straight off the mandrel. The resin for this layup was a System 3000 resin from Fiberglass. System 3000 resin is awesome because it has a high service temperature, so I can use it for high-speed rocket flight without worrying about it softening under the high temperatures. The System's 3000 resin does require a post-cure though, so there's a little more work to do after I make the tube than if I used a room temperature cure resin system. Now the trick to doing composites is always to do the preparation before you mix any epoxy. Once you have all the materials cut, weighed, and measured, the only real trick to doing this is getting a really tight wrap around your mandrel. The tighter your initial wrap on the mandrel, the better your tube is going to come out. Once I mix the epoxy, I weigh it out. I'm targeting a 1-to-1 ratio between resin and fiber. Typically, you'd want to have slightly less resin than fiber in your layup by mass. However, I'm going to perform a step later to help squeeze out extra epoxy. So I'm starting with a little extra epoxy now. I squeegee the resin into the fiber while it's laying on the table. This is a much easier shape and form factor to work with. Then, I roll the tube across the fiber on the table to get a tight wrap. Pretty much the only trick here is getting a tight wrap. The tighter the wrap is, the better your final result is going to be. A tight wrap will help you avoid wrinkles and other inconsistencies in the tube, which will reduce its strength and also impact its cosmetic appearance. Once the 2-ounce fiberglass is smoothed down, I wrap the entire tube in a layer of high-temperature heat shrink tape. This heat shrink tape will provide compression and squeeze out the extra epoxy I don't want in the tube, while leaving a smooth surface finish on top. To wrap the tape, I hold down the first end with a layer of flash tape, I wrap the tape down and back, and then I hold down the other end of the tape with another layer of flash tape. Securing both ends of the tape allows the heat shrink to firmly compress the tube evenly as you heat it up. Since the cure cycle on this tube can't be performed until after the epoxy sets up, I need to shrink the heat shrink tape now so that it squeezes out the excess epoxy while it's still liquid. 30 minutes or so after I activate the heat shrink tape, I wipe down the outside of the tube with isopropyl alcohol to remove any extra epoxy. This just makes the tape easier to remove later. After the tube's set up for about 12 hours, I put it into my DIY curing oven. I have 4 thermistors in this oven that allow me to monitor the temperature in different portions of the oven, and I use a hot air gun to control the temperature. The tube needs to go through a 9-hour cure cycle, so it takes most of the day, and I try and do multiple tubes at once to make the process a little more efficient. It's really important when you're doing the cure cycle not to heat the tube up or cool it down too quickly, as that can damage the epoxy and reduce the strength of the layup. Once the tube had cured, I removed the Teflese tape holding the mylar film onto the mandrel, and I was able to slide the mandrel out from inside of the tube. The mylar can be pulled out from inside of the tube, leaving a clean surface on the inside. Being able to make custom carbon fiber tubes opens up a world of possibilities for a lot of projects, so hopefully you found this video helpful. If you're making something cool with carbon fiber, let me know in the comments down below. Now I've got a lot of work to get this rocket ready to fly in a couple of weeks here, so I'm going to get back to it, but until then, good luck and Godspeed.